Hello, AP Calculus students. I am coming to you today with a lesson on integrals using U-substitution. So we're going to do 4 warm-up questions. We'll talk about some special integral properties, and then I'll give you a few examples on integrals using U-substitution, and then hopefully you'll have enough to get started on the practice. So our objective is just going to be integrating using U-substitution. That's really the basic objective for today. So here it is. We're on objective 6.9 or topic 6.9, integration using substitution. So we'll do a warm up, some integration formulas, guided notes, and practice, and then your homework will be the Unit 6 review. All right, so I'm going to go ahead and first start with the warm up. I'm going to do this lesson on paper. So this will just be mostly a pretty low tech lesson. So let's go ahead and get started. So here's your warm up. Go ahead and pause the video and take as much time as you need to find the integrals of these four functions. So I'm hoping you've taken all the time that you need. These are the results, or they should be the answers. So all of these are polynomials. So we're just using the power rule, right? Adding 1 to the exponent and then taking whatever exponent our new exponent is and treating it as the new denominator. And then we always add our trusty plus c at the end to account for the fact that there could be any constant in the integral. Okay, and then this is just from simplifying, right? So for example, here you have 20 over 10, that would just be 2, and so forth. So all the constant multiples for each separate term are just simplified, right? Negative 77 over 11 is negative 7, and so forth. Okay, and then one of the things just to be careful about, because people make this mistake a lot, is adding 1 to -5 would be -4. Some people go backwards by accident because, 5 plus 1 is 6, but -5 plus 1 is -4, and so on. Okay, all right, so hopefully that warm-up went okay. What I want to do now is talk about U-substitution. So if we had, for example, an equation or an integrand that we were supposed to integrate that was a function within a function, some kind of composite function, we have a rule for that. And that is the integral of f of g of x times the derivative of g of x dx is equal to the integral of f of u du, which is the antiderivative of u plus c. And what we're going to do is substitute u for the inside function, the g of x, and then du is going to be g prime of x. And I'll show you how this works. It's not that tricky. It's just something that will come with practice. Okay. All right. Before I go forward with that, I do want to remind ourselves that we do have integral rules. So right here, these are just some special, I shouldn't say rules, I should say formulas. These are some special integration formulas. Okay, so just if you need to screenshot them, they're in the slides in our Canvas modules, but if you need a screenshot or some sort of a pause to remember, these are some of our special derivatives. All right. So now let's go ahead and do a few examples. So I'm going to go back to the second camera right here. So we're going to do a few examples. So again, this really comes from the idea of the chain rule and the idea of composite functions. So let's look at example A first. The integral of 2x times x squared plus 1 to the 4th dx. Okay, so you can see how this is a composite function, right? There's an inside function, x squared plus 1. And then the outside operation is that it's raised to the 4th power, and then it's multiplied by this 2x. So let's go ahead and start. Sometimes with integration, you have to be a little bit patient with your process and see, sometimes you'll start off on one path and realize it's not going well, and then go off on another path. So always just start with the best information you have. So the best information I have right now is that this is a composite function. The inner function is x squared plus 1. So let's go ahead and just let that be our u. X squared plus 1 is going to be our u, right? So that's our u equals gx. And now what we're going to do is find du, or du dx, which is g prime of x, right? So I'm going to go ahead and do that. Du dx is the derivative of this function. So the derivative of x squared plus 1 is just 2x. Okay. All right, now I'm going to do a little bit of algebra, because I'm going to substitute in u for x squared plus 1, but I also want to substitute dx because I want to be taking this derivative with, or the integral with respect to du. So I'm going to go ahead and translate this into that this is dx equals du over 2x. Right, so I'm just basically solving for dx there. So dx equals du over 2x. Okay, so now I have everything I need to substitute. So integral of the 2x I didn't do anything with, so that's just going to stay. And then I'm going to substitute in here the u to the 4th, and then I'm going to substitute for dx. Okay, so here goes, I'm going to keep with the yellow there, u to the 4th, okay, u to the 4th, times, instead of dx, I'm going to substitute in that du over 2x, du over 2x, okay. All right, so all we've done is just substitute. We've said, okay, we're going to let u be x squared plus 1. We just plug that in there, right? And then we plug in du over 2x for dx. All right. So now we're going to see that some interesting things are going to happen. We have 2x divided by 2x. 2x divided by 2x is 1. So that's going to leave us with the integral of u to the 4th du. And we know how to do that. That's a pretty straightforward problem to solve. It's going to be u to the 5th over 5 plus c. Right? And now what we can do is substitute our u back in, right? So now we have that our integral is going to be x squared plus 1 to the 5th over 5 plus c. And that's it. That's all we have to do on that one. Okay, I'll do a couple more. So the integral of secant squared x times tangent of x plus 3 dx. Okay, so again, sometimes it's tricky to pick a u, but I'm going to go ahead and pick, I know that secant squared is the derivative of tangent. So I'm going to think, okay, well, maybe I'll pick tan x plus 3 as my u. Again, sometimes you'll start off and you'll pick a different one. And if it becomes a struggle, you can kind of start over again and pick another one. But I kind of know in my mind that secant squared x and tangent x have that relationship. So I'm going to say we're going to let u equal tangent of x plus 3. I'm going to say that du dx, du with respect to dx, is equal to secant squared x. Right, that's the derivative of tangent. And then I'll do that algebra again, that dx is equal to du over secant squared of x. Okay, and now I can substitute. So integral of secant squared x times, I'm going to put this u in, u substitution. And then instead of dx, I'm going to replace dx with du over secant squared x. All right. So again, just like as in example A, some interesting things are going to happen. Secant squared divided by secant squared is 1. So now I just have the integral of u du. Okay, and I know how to do that. That's u squared over 2 plus c. And then I can just substitute back in, oh, that I didn't give myself enough space. Substitute back in tangent of x plus 3 squared over 2 plus c. Tangent of x plus 3. Let me rewrite. It's so small. This is an answer, but let me just rewrite it because this is an instructional video and I want it to make sense. All right, tangent of x plus 3 squared over 2 plus c. All right. All right, so that's example 2. Let's do the last 2, and then hopefully you'll be all set for practice. All right, integral of 3 times e to the 3x dx. I think my inner function is going to be what's in the exponent here. So I'm going to treat my u as equal to 3x. And then of course my du dx is 3, derivative of u is 3. And then using my algebra, dx is du over 3. Now I substitute integral of 3 times e to the u. And then I'm going to put in place of dx, I'm going to put du over 3. I see that my 3's divide out. So that leaves me with the integral of e to the u du, which is just e to the u plus c. And now I just need to substitute my u back in. So e to the 3x plus is my integral. That's it. Okay. For our last problem, we have another trig problem. So here we go. Integral of 5 cosine of 5x dx. All right, so what looks like my inside function, 5x. So we'll say u is 5x. We'll say du dx is 5. And then if I solve for dx, I get that dx is 5 is du over 5. Okay. Now I have to do my substitution. Integral of 5 cosine of u. And then instead of dx, I'm going to substitute in du over 5. And then lo and behold, 5's divide out. So I have the integral of cosine of u du, which I know, because I know my trig integrals so well, and so do you, is going to be sine of u plus c. So my final answer, our final answer would be sine of 5x plus c. Let's just substitute that u back in at the end. All right. All right, so I hope these examples helped. I hope you're ready to go ahead and work on some of the practice. And please, as always, email me if you have any questions. And thank you so much for watching. Have a great day.